So, good morning to all of you once again. Now, I am really privileged to be here. I would like to thank the Department of Management or Business Administration, Dr. P.C. Roy, Academy of Professional Courses, as well as the management of this particular college, that they have found me suitable to be invited here in this particular session. So, till date, I have not taken any classes as usual like this, formal classes, because what I am taught or what we are teaching here, it is basically banking and finance and all related, and bank staff are there. So, I am not a practical statistician, nothing having a statistics degree, but yes, I have worked in my PhD thesis with non-parametric method. So I will just provide you certain insights regarding the practical aspects of the non-parametric tools which we use for analysis in various domains of our work. Okay. So before I start with what do you mean by parameter? Can I have a pen? Marker. Yes. So what do you mean by this parameter? Before I go for non-parametric, we should know what is a parameter. All are comfortable in English? Okay. So any answer regarding what is a parameter?
So parameter is a variable.
Yes, parameter is a variable, okay. Any other answers?
Some properties.
Yes, some properties means parameter is used to express some properties. Properties related to what? Properties related to some population. Properties related to a certain population. Okay. Population, as you know, it is only U size. So properties which are related to a certain population, like you call it a mean, that is the average. So mean of population. So that is being expressed by a parameter. So some sort of distribution is available here. Means distribution is the same shape, how this parameter is distributed. So some sort of distribution is available here. But when we talk about statistic, so when we talk about statistics, this is related to not population, this is related to sample. So these two things are different. One is a parameter which is inferring to the particular population, and second one is the statistic which is referring to a particular sample. Now, when we talk about parameter, so then it is very clear that we are talking about distribution of the population. It's okay. So when we will be talking about non-parameter or non-parametric, means it does not have nothing to do with the distribution of the data or distribution, whatever it is. That's why it is a non-parametric. Okay, so that means it is a distribution free also. What we do in the parameter, that we confirm that the distribution is like this. That means a bell-shaped curve. Many of you have seen this bell-shaped curve. Okay, and this is considered as a normal distribution. Right? This is the mean, which is equal to median. This is the thing. Now, what about those distributions which are not normal? Everything does not remain normal. When you analyze a stock market or share market data, it is nothing, it is nowhere it is going to be a normal distribution. Chances are very rare. When you are analyzing certain data which have outliers. Outliers are understand. For example, I was working with my PhD data. When I was working with systemic risks. Now systemic risk is being quantified in terms of $1 billion. Now, during a crisis period, for example, it was COVID-19, what had happened, the systemic risks all of a sudden it increased. During global financial crisis period, it all of a sudden it jumped. Maybe 3-fold, 4-fold, 5-fold, it increased. So you are getting some outliers which are not within the normal. Otherwise the things are normal, but you are getting certain outliers. So this type of distributions or this type of analysis again, it requires some sort of other tools. Yes, time series analysis can be used, but other tools are also there which can help to analyze this particular data. And that's the use of non-parametric. Non-parametric, is to be used, it has gotten certain characters. For example, whenever we are talking about parametric statistics, what we are talking about, that it can be quantified. For example, yes, height of 50 students in a particular class. You can quantify either in centimeter or in inches. And then you can find the mean also, you can find all other parameters. But what about things which cannot be quantified? For example, how you are carrying out a survey on a batch of students or on a batch of persons in a particular class, and you are finding or you are going to analyze that how much is the usage in the social media, maybe Facebook, maybe Twitter, maybe Instagram, whether it is high, low or medium. So in this case you are not quantifying. What you are doing is taking care of certain other data that cannot be quantified. You are saying that you are using the social media at a very high rate. Someone is not seeing at all. So there is no use of the social media. So that cannot be quantified. So things which can be quantified. So two things are coming. Number one, things which can be quantified can be expressed with this parametric statistics. Things which cannot be quantified can be expressed with non-parametric statistics. Okay. And second one is that one is distribution free and this is not. A distribution free, this is a normal distribution. Okay. Be interactive in the class. Otherwise, I will feel that I am taking for the first time. So it gives a feeling like me that some things become very, because statistics is a subject which is a boring subject actually. It takes a long time to understand. I remember one question in my agriculture graduate days. One question was put in the statistics final term and examination. That one person is walking to the side of the road and one person is walking at the middle of the road. So what are the expectations that the chances of accident of that particular person who is walking at the middle of the road is highest? So that type of things are there. So it has got certain difference. So non-parametric and parametric. First of all, we need to know what are the basic differences. So one is qualitative, one is quantitative, and second one is this bell-shaped curve. You should remember this. One is having a normal distribution and the other is distribution free. So these are sometimes known as distribution free also. Non-parametric or distribution free statistics. So two things have been known. Then, yes, okay, then non-parametric. Then some parameters, if they are not there, then what will happen? We have to also take care of other measures, because when you find out the height, suppose I am taking the height. Height of, suppose it is 10. 10 students are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Now, this I am doing that, this is suppose this is something around this is 2 meters, this is 3, this is 4, this is 5 meters, and then again this is 2, 3, 4, 5, 6, Suppose these are the height of different types of plants, of the same species which I have taken, and we have utilized different types of fertilizers and all those things, whatever it is there. So, the first thing is that when you go for a parametric test, you will just find out the mean, to find out the average height. But when you go for a non-parametric test, it will be based upon not mean. It will be based upon median. First of all, it will be based upon median. So, median is important here. So, in parametric, mean was important, but here in non-parametric, not the mean, median is important. Because mean I am doing the average, but median, what is that? That is the middlemost observation in a particular data. So, middlemost observation, then what thing you have to do? You will have to again arrange it. You will have to arrange it. For example, I have here 2, then here also 2. So this is the first observation and this is the 5th observation. Then I have got 3, then it is the 2nd observation and then 3, it is the 6th observation, and accordingly I am going to classify. Now I will find out what is the median. So my job is that, now suppose you are going to find out that yes, we are going to find out the thing that whether the median it is close to 5. We are going to find out whether it is close to 5. That is our motto. That whether this median is close to 5. What we have to do, the next step, what you are telling, that is the next step. Or I can put a sign also. When I am putting a sign, that is known as sign test. How to put a sign? Either it is positive median or negative median. If I consider that median should be 5, this is my consideration that the median should be 5. Now, if the median should be 5, now this is -3, this is -3, this is -2, and this is so negative, and 6 is also there, means positive +1. So both options are there. Minus options, positive options, as well as negative options. So since both the options are there, then we have to calculate it, how many negative are there and how many positive are there. I will show you everything, how to calculate it and how to do it. So this is simply put as a sign test. Sign test is one of the tests in non-parametric, and this is a single sample sign test. You can go for paired sign test also. Paired sign test means 2 samples will be there, and you have to compare whether the medians of these 2 samples are same. For example, height and weight of particular individuals in a particular group. So in this case, you can have a data that yes, height should be this much, median should be this much, or median should be below that or equal to that. So what we are calculating, it is the median. So when we are calculating the median, that means 50-50. Middlemost means 50-50. So in that case, our null hypothesis will be this one. Simply if I put it like this, our null hypothesis means probability should be 50. And our alternate hypothesis will be okay. And since I am taking both the factors, positive as well as negative, so it is sometimes called binomial distribution, means 2 types of things are there. You know, when you toss a coin, I am tossing one coin. So there are 2 probabilities. Either I am going to get a head or I am going to get a tail. So this type of outcome, 2 types of outcomes are there. Similarly here, there are only 2 types of outcomes. Either it will be a positive outcome, either it will be positive or negative, not zero. Because I will replace that particular zero. If our median and the observation, these are closed or safe, that has to be replaced out of the data. So this is one test that is known as sign test. The first non-parametric test. That can be done with a single sample, that can be done with two samples. Okay. Now coming to another topic, that is the rank. So before going into rank means what? Suppose in a class, there are, in your class, some of the faculty members are there, they are marking, and they have got 20 students. And they have marked one student out of 190, someone is 95, someone is 92, like this. So then you can rank the highest one and the lowest one. You can rank accordingly. Okay. So that is based upon the rank. Why rank? If you take the data, since the data is not normally distributed, we will not get the proper result. So that's why what we are doing, that we are ranking them. We are ranking them according to their place, how much rank one has achieved. Okay. So what happens, suppose I carry out a ranking of the students who have got the marks in a particular subject like this. Suppose 5 students are there. Someone has got 90, someone has got 91, another one has got 90, then 92 and 97. So these are 5 students. We can rank them. First it will be 90, then 90, then 91, then 92, then 97. This is your rank. 1, then 2, then 3, then 4. Just put the ranking like this. Now what about this 90 and 90? 2 students have got 90. How to rank them? Very simple process. Just average them. Okay, so if 2 students have got 90 and 90, then 1 plus 2 divided by 2. It becomes 1.5. So that means 90 is 1.5, then 90 is 1.5, 91, this is 3, 92, this is 4, and 97, this is 5. I have got my ranks. Very simple process. We will deal with one example also. So, why ranking is being done here? Because to get certain results out of it or get it with the help of certain statistics. So, ranking. Non-parametric, it is based upon ranking. So, non-parametric test, they will mostly based upon ranking, except that particular sign test. So, what do we do? Another test, that is the, another test is there, that is Wilcoxon rank sum method. Sometimes we also use man-wide test. So these are some of the tests. So sign test, Wilcoxon rank test, man-wide test. Man-wide test and your this Wilcoxon rank sum test, it is based upon this rank. Now, these are more or less close to your t-test, whatever it is there, t-test and parameter. But what about another thing that is known as ANOVA? So if you feel any problem in between, you can tell, no problem. Interaction should be there. Otherwise, the class becomes very monotonous.
What is the difference between this method and ANOVA method?
Yes, I am coming. So what is ANOVA? Analysis of variance. Let us understand it first. Now, analysis of variance means how much variance is there in the data. Now, how to understand this? Suppose there are 3 particular populations. Okay. And I have got 3 types of curve. This one is one. This is another curve. And this is another. So, this is one curve. So I have got 3. This is mu1, that is mu2, and this is mu. Okay. So here you can find it that what is this is the mean. Now what is the difference within and what is the difference between? Okay. What is the difference between each particular? This one. So what is the difference? Variance. Okay. That I am getting, that is within. That is within, not within. And second is that another term is there. Again I am putting these 3 terms. Okay. Now again a base separator. Now this is the meaning of this base separator. This is the meaning. What is the distance between this? What is the distance between this? What is the distance between this? Okay. So now I am going to find the ratio. What is the difference between and what is the difference within? That is what. If I simply put it like this, that is analysis of variance. Means what is the variance within and what is the variance between? Okay. So in ANOVA you will get some sort of test there in parametric, but here in non-parametric we have got mainly 2 to 3 tests. Number 1, that is we carry out Kruskal-Wallis test. So Kruskal-Wallis test, it is sometimes known as one-way ANOVA. So what is a one-way ANOVA and what is two-way ANOVA? Then there is also things to say. One-way ANOVA means what is the there? Within. And two-way ANOVA? Within. Okay. If I put it in form of an example, that is one-way ANOVA, sometimes you see that you are going to check suppose there is a particular brand. You are taking Coke, you are taking Pepsi, you are taking some other brand. What is the taste you feel? The difference in taste, the blind taste. Or suppose you see there is certain type. For example, one particular medicine has been given before treatment for pain relief. What is the situation before treatment? Means giving the before taking the medicine. What is the perception about the knee joint pain? What is the perception after taking the medicine? And in between that. Okay. And two-way ANOVA, suppose I am putting the salary that is independent variable here also. The time which I take, the 3 particular time. Now, two-way ANOVA, suppose it is salary. Salary is a variable and which is dependent upon a lot many factors. For example, degree, sex, education, and all those things. That you can also express. That is Kruskal-Wallis test. Then, two-way ANOVA. Two-way ANOVA means prediction. Now, how the salary is being affected by the degree, how the salary is being affected by the sex, or how the salary is affected by the social status or something like that. In that case, what you do, normally, you may extend this Kruskal-Wallis based upon ranking, and then ranking to be put in a parametric test, or better, go for logistic regression. I will not go for logistic regression today because it takes a lot of time. Because logistic regression means logic. Logic. If I put in a simple word, what is that? That is law of odds. If I am going very fast, then you can interrupt, no problem. Because I am also going very fast. I will not complete this. So log of odds. So what is the odd that we have to understand? Suppose I am tossing a particular coin and the probability of success means coming the head. If head comes, then it will be my success. And if I am tossing the coin, suppose probability of success that is coming ahead, it is 0.8. Since probability should be within 1, so that means the failure will be 1 minus 0.8, 0.2. So odds will be referred by 0.8 by 0.2. Means our odds, that is chances of odds in the success, it is 4. That means your probability is ranging from 0 to 1, but odds can take any value. It can take a minus infinity to plus infinity. Any value can take. Actually, when I was working with my thesis, I am giving certain examples before. So, there were certain situations that there were not many outliers were there in the data. And I wanted to find out that what are the inferences, what classification, that what it happens during the COVID time and what it happened during the global financial crisis period and other period also. So in that case, I have used this logistic regression for prediction purpose only. Because it is used for prediction purpose. That's why I told you, suppose salary is a variable which I am going to compare with the education, social status as well as sex. So in that case, this logistic regression can help us to predict how it is being influenced. So in that case, we are going to find out this log of odds. Then this is log, and log of this is your log of odds. Why log? Because it can range from minus infinity to plus infinity. Until unless you go for a logarithmic, it will not be converted and it will not be expressed properly. That's why it is log of odds. So we will not deal with this particular logistic regression today. Another non-parametric test, it is the Friedman test. Okay, so Friedman test and Kruskal-Wallis test, what is the basic difference? Kruskal-Wallis, it is one-way ANOVA, and Friedman actually, it is repeated measure ANOVA. Repeated measure. So repeated measure ANOVA means there is a single sample only and we are giving more than 3. So Kruskal-Wallis is also more than 2. ANOVA is more than 2. So similarly, if it is within 2, then what will be the test in parametric? We will normally use the t-test or paired t-test. Yes. Otherwise, in case of Kruskal-Wallis, it is more than 2. That's why I told you, 3 parameters are there. Suppose there is a medicine, particular medicine. So I want to find out the efficacy of the medicine in teeth problems. So one situation is before applying the medicine, one situation it is during application of the medicine, and third one is after application of the medicine. How much relief the patients are having. But in Friedman test, it is a repeated measure, and what means the single sample will be subjected and the treatment will be repeated. This sample will be group will be repeated. Single group will be repeated. For example, I have got a particular variety, suppose it is X variety of a paddy, where I am putting this much fertilizer, 1/4 of fertilizer. Another one is there, same variety, I am putting half the dose, and third one is that I am putting full dose. So what will be the difference in the yield, or what are the differences? So that I am going to check out in the framework. So we are going to study today, that was only the introduction part. I will start the PPT now. We are going to study sign test, then Wilcoxon rank sum test, Mann-Whiteley test, Kruskal-Wallis test, and last one is the Friedman test. Okay. Now any problem or anything you want to, you will ask, or I will start my PPT.
Sir, last question.
Last question.
Last question. Friedman test.
Friedman test. Friedman test, it is referred to as a repeated ANOVA or repeated measure test. Repeated method why? The same sample will be repeated. I will show you. When you see the PPT or the example, it will make you clear what we are going to do. For example, there is a variety of paddy. Suppose it is X variety of the paddy. Now this X variety of the paddy, it is subjected to three fertilizer doses. Three fertilizer doses. One is the total full dose is 1, and in one case I am giving 1/4 dose, another case I am giving the half dose, and the third one is the full dose. So what will be the effect of this particular treatment? Okay. So this particular repeated measure will be taken care of by treatment. In that case, we will arrange the data again in rows, and that ranking is something different. That ranking will be this in this way, in the row direction. Suppose this is your 1, 2, and 3. So this will move like this. Ranking first, ranking 2, and that I will show you. So these are the major tests which are available in non-parametric. Now, what are the advantages of field in case of non-parametric? Number one, it is a distribution field, so you can apply anywhere, except when the data is having a normal distribution. Number two, regarding power of the test, you know the power. What is the power of the test? I have not learned many things about statistics, so I am just taking a normal class. It is not a very official class. What is the power of the test?
Copy error free.
Yes. How much error free is that test? That is the probability. Probability of type 2 error. How much it is free? Type 2 error means we have type 2 and type 1 error. What are these?
Random and hidden.
Random and determinant. He is taking a technical language. I will tell in a simple language that your null hypothesis is false. What you are saying? Okay. So put it in a simple words. Okay. Otherwise it will be very difficult. So we will just a quick recap of our PPT. What are the things are there? Then again I will come. So basically what we will be doing today, we will not study the theory part. We will study the practical part, how to do it and how to get results of it. Because a lot many big names are there also. I am the last person to come. I think up to this it is clear for all of you. Okay, thank you. His pointer is there. I can change the slide. Can I get the pointer? And can I get the slide changer also? Slide changer is not also. Okay. Slide changer is not also. Okay. So parameter that I told you that something that decides or the limits the way the something can be done. So basic difference, that is fixed parameter, no fixed parameter, and parametric statistics and no non-parametric statistics. And this is parametric test and non-parametric. These are the differences which I already told you. So here you can see in parametric test, assumptions are being made regarding the population. The assumptions that yes, mean will be this much or Here there is no assumptions about the population, no distribution. But here the assumption is there that yes, probability distribution it is going to be normal. Then central tendency, null body central tendency, that is the mean. But here it is median. And it is applicable for variables, but this one is applicable for both variables and averages. Now you see, I have told you that it is applicable in quantitative and this is qualitative. This is okay. But in non-parametric, you also get quantitative data. For example, I showed you that is the marks obtained by suppose 20 students in an exam. That is a quantitative data. But what we are doing, we are ranking it to get the result. So this ranking means transformation of the data. We are transforming that particular data so that we can get a result out of it. And here the null hypothesis, it is free of parameters, and here it is based on the parameters of the population distribution. Now, what is the interval data? And what is a nominal data? What is the interval data?
The data we are getting from a particular interval.
Yes. Suppose I am putting the income of the persons. It is greater than 1 lakh. Then again 80,000 to 90,000. Then your 70,000 to 60,000 like this. I am classifying the data in a certain interval. Okay, that is interval data. And what about this nominal data? Category. For example, you are doing a poll or you are doing a survey, and there you are taking care of this. Yes, what is the market rate of selling? How much sellability of a particular product? That whether it is easily sellable, or it is very difficult to sell, or it is okay, average selling of that particular product. So that's the poll opinion. Then here you carry out, when two groups are there, independent measure of the t-test. Here you carry out mathematical test. Then more than two groups, one way independent and over, you have to carry out Wilcoxon and repeated measure. Two conditions are there. Then you can go for Wilcoxon, and more than two, you will go for failure. These are the basic differences in the test of the parametric and non-parametric.
Sir, the last slide,
Yes.
can you go back just for last slide?
Last to last slide, please.
This one.
Yes, sir.
Here it is written more powerful and less powerful.
Yeah.
This is the powerful.
Powerfulness, I have told you how to take care of the power of the test. Always you see the non-parametric, it is less powerful because it is, first of all, it is distribution field. But here it is more powerful means the prediction. Prediction power, it is more. That means what I told you, power of a test. So what the power of a test, there is the probability of the chances of getting an error-free result. So power of the test, it is more in case of normal distribution. But in case of this non-parametric test, the power is less. That's why in case of non-parametric, what I told, for prediction, you do not use this type of test. If it is a time series data, you go for time series analysis, or if it is like that particular data, you go for a logistic regression. Regression, why you go? For prediction, you cannot use all those things. Yes, if it is a small sample, you can use it. Otherwise, big samples or time series data you are getting, 14 years or 15 years, you have to change your methods. Okay? So in that case, for prediction, you use something else that I told you. Yes.
Sir, previous session we know that for non-parametric case, we can use the mean value of this particular data set.
Yes.
Sir, for this, why we are using?
So what is the basic difference between mean and median? Mean is the middlemost observation. In non-parametric, the data is totally distribution free. Then how we are going to get a good mean? How we are going to get? Suppose I am showing you the data. Now this is 100 and this is 1000. This is 2000. and this is 3000. Okay, and another observation, suppose this is 4000, and this is again 5000. Not many outliers are there. Mean means what? It is the measure of the central tendency. Means close to the center. Do you feel something is close to the center in data? So that's why we are using the middlemost observation. Mean always, it is known as the measure of the central tendency. Means how much mean then your variance. Variance means dispersion from the mean. Okay, so that's why we are describing that particular thing. Nothing else.
So for this, we can also use the mod.
What is a mod? It is the number data which is coming more frequently, the highest number of times. So we cannot use also this. If you take only the highest number of times, you might feel that in case of more frequent, only 2 or 3 observations are coming, or large number of observations are coming. In that case, what may happen? Suppose a case is there, normal situation and abnormal situation. Okay. Suppose you are finding out the celebrity of a particular share or the price of a particular share during COVID period and price of a particular share during the normal period. And when you are taking the mode, when you finding that price of the share during the normal times, it will fetch it only. Then what about the price of the share during the abnormal times? Is it going to get a good reliable estimate? That's why we are using the middlemost observation. If I take a mode, suppose I am going to analyze the share price of a particular company or anything. So during normal times it will be higher than during the abnormal times. So when you are taking the mode, all the data will be fetched from the normal time. Then what about the abnormal? That has to be also taken. So that's why I am carrying out median, means ranking 50-50. That's why I told you, always we check the median, whether the median of these two groups are same. The median of this, in case of sign test, we are going to check out the median, that whether it is 50%. If it is within that 50%, then it is your null hypothesis, it is okay. Otherwise, it is okay.
For media, you have to shorten the data set.
Ascending order.
Ascending in
Yes,
ascending,
yes, yes.
after that
Yes,
you
yes.
use the median.
Yes,
statistic.
yes.
So for every time we have to shorten the data.
Yes.
Every time.
In case of non-parametric, for ranking also, you have to sort the data. For carrying out the median analysis, you have to sort.
Suppose it's a number, that's why we are sorting. Suppose we have a data set is non-numeric value.
Yes.
So for this we have
Neutral numeric value means
non-numeric value.
non-numeric value means
That takes data.
yes. Positive, negative. Okay. That you can also do in case of non-parametric. Why not you can do? That's why non-parametric is there.
So how so that
In that case, we will not use that particular test. We will use something else. We will go for some logistic regression, or we will use how much it is. Suppose I have a data, I have a survey result. Survey result, that is your this survey on social media. Okay. Now these are 1, 2, 3, 4, 5 numbers. They are using very high. Their usage is low, it is medium. And it is again low. And it is high. Okay? Now for me, I have only 3 parameters here, low, medium and high. Okay. Now suppose I say high is 3, low is 1 and medium is 2. Now replace the values.
also converted the
You can also convert it, you can get the result, or you can directly put it into logistic regression. It will help to predict you that which is here it is relevant. Whether the persons are highly addicted to the social media, or they are using the social media, or low, or any of these features. That is the beauty of the non-parametric test. What you cannot do there, because in nature also, in field experiment also, or in your finance experiments also, Data is not natural. Either you have to convert it into, transform the data, you can transform the data into your, this natural, the normal, through logarithmic transformation, or you can go for box and box transform, anyway, what you can use. Then you can use this parameter. When the data becomes normal, you can use it. No problem. Otherwise, you cannot use it. Okay. So you can move it. You can move it. We have already discussed. Okay. So, what are the advantages of the non-parallel? It can be used in all scales. Nothing there is very extra, nothing is different. It is easier to compute, but sometimes it becomes very difficult. When it contains 2000 or 2000 data sets, then you have to take care of package or any other thing. You can easily calculate it. Then it makes very fewer assumption about the particular data. Nothing. It need not involve the population parameter. That's why I told you. Non-parameters. Okay. Result may be exact as parametric and can work on rank data. This is the particular thing that it can rank the data. When you are doing the ranking, you are discarding the total data. You are just taking care of the ranks. So these are the advantages, and disadvantages are also there. You may waste information. You are not getting the good result. Parametric model, it is more efficient that I told you. Then it is very difficult to compute. Sometimes, suppose you are taking care of 10,000 data in a single shot. It is very difficult to compute. Putting in Excel and all those things. And tables are also not widely available to calculate. So these are some of the equivalence parametric and non-parametric space, and this suppose Wilcoxon rank space, that is your paired t list, means two independent parameters of groups will be there. Okay. That might mean it is unpaired. They are not related. Paired means they are related and they are unrelated. Then Spearman correlation, I will not deal with that. Normally, what do you mean by correlation? What is a correlation? Relation between two variables. What do we say? That if it is positive, then if one increases, other will also increase. So plus plus. And if it is negative, if one will increase, the other will become negative. Normally this type of thing. But here, in Spearman actually, we go for a rank correlation. Based upon the rank, we will decide how to do it. Then Kruskal ones, that is one way aroma, and Friedman, that is the repeated that I have told you. The details are okay. Scientists. Now, regarding the scientist. So, assumption is that the population distribution is continuous and it is the statistical significance of the median value. Means, suppose I am taking the marks of 5 students. Now, someone has got 90, then 91, then 92, then 93, and 98. Okay. So, now if I hypothesize that, my null hypothesis is that the median marks is, it is 95. Suppose it is 95. Now I am going to check it through the scientist whether it is close to 95 or not. So null hypothesis will be my median is not equal to 95. So in this case, we will put a sign before it, positive sign or negative sign. If I put it, if I carry out this, the 95, it is my median, then this will be minus, this will be minus, this will be minus, this will be minus, this will be plus. So how many minus? 4. Only 1 minus. In this way, we calculate the sign test. That I will show also. You can move to the next place. Suppose there are two particular brands. One is Amul butter and another one is your mother dairy. There are two brands. And sample study it was carried out on 36 consumer whether they preferred the taste of the particular brand. So on the basis of the sample, 18 preferred Amul and 12 preferred Mother Dairy and 6 had no preference. So suppose it is marked by plus and minus. So analysis of the sample size it is 30. We can move to the next. And my null hypothesis will be there is a preference over the particular brand or there is no preference over the particular brand. In that case, you are going to get the sigma. Why mu has been calculated? This is the mean of the distribution. Sampling distribution, whether there is any brand preference or not. We will do it with help of an example also when you see the Excel sheet. So if I get here the Z statistics, so Z x minus mu by sigma. Okay, that is the observation. There is the mean and there is the variance. So if I find out the Z statistics here, why it is 1.96? What do you mean by this 1.96? If I see this Bell's effect curve, that is in case of normal distribution, what happens? This is your mean. It can be classified into two parts. This is 0, this is minus 1, this is plus 1, plus 2, minus 2. So this particular area, it is coming under 95%. And so it is coming under 2. That is the standard deviation around the mean. So 95% area, that means it is a normal distribution. That's why we are taking it whether Z is less than 1.96 or it is greater than 1.96. So here, conclusion is that we cannot reject. Since Z statistics, it is coming as less than. There is insufficient evidence to conclude that there is a preference in the two brands of the mother. So we will study with another example. Suppose you consider the weight of the 15 females. There is a data 15, 58, 59, 60, 61. This is the data. Now you consider that this 64 inches or this 64 inches is the median that you are considering. You are going to test it whether the median is 64 inches or not. So null hypothesis will be the median height it is 64 inches and alternative hypothesis will be it is greater than 64. So two things are only there. You see the ranking has been done like this. Sorry, ranking, the scientist has been put there. So first it was 58. I have considered 64. So it is a negative 58 minus 64. Then 59, 64, again negative. Then 60, 64, again negative. Then 61 and 64, again negative. Then 64, 64, then 0. Then 65, 64 plus 66, 64. So how many you count? How many plus and how many minus? One is 0. Plus sign it is 8. Minus sign it is 6. And 0 is only 1. P value it is greater than or equal to because 8 are positive side. Now, why we are taking binomial distribution? Just understand this here. There are only two situations which can occur here. Either it is greater above the median or it is below the median. Two situations are only there. Plus signs, they are above the median. Minus signs, they are below the median. So only two types of situations can occur. That's why we are considering the mean, that is the 15 samples were there. we are considering the p-value as 0.79. So we are accepting since it should be more or less greater than or equal to, so it is less than your at alpha level of significance we are getting less value. So conclusion is that you cannot take 64 inches on the basis of the observation. So your null hypothesis it will be accepted in this case. Okay. So in the first sample, the difference is 1, the ranking is 1, then final rank is 1. Second one, the difference is 2, ranking is 2, final rank is 2. Third sample, the difference is 3, both the things. Both the samples, the different, your difference is 3, but your ranking it is, final ranking it is 3.5. In the fourth one, the difference it is 4 and ranking it is 5. 4 and 5. So here we are considering only 4 because we have shown the difference. There are 5 4s and it has got different rank. In one sample it has got a 4th rank, in the second it has got a 5th, again in the 4th and 5th this wise, and there are 7 ranks. So we are going to get it 7. We will do another exercise so that it will get a more clarity on this particular ranking because I want you to do the ranking yourself. That you have to do it. Okay. So similarly, we combine the positive and the negative rank now. Positive means whatever rank you are getting here as a positive, negative, it is 3.5. So it is 3.5, then it is positive, it is 7 because positive and negative it is coming from this. If it is negative, then it has been put as a W negative, and if it is positive, it has been put as a W positive. So accordingly, we calculate how much positive rank are there and how much negative rank are there, and accordingly we calculate the expected value. Expected value means n into n plus 1 by 4, and we get around your 126.5, and we also calculate the standard deviation. After calculating the standard deviation, we calculate the Z test, that is x minus mu by 6. So mean is there, x is also there, that is your normal minimum value, that is out of the positive and negative, you are going to take the minimum value. Positive signs, it is 106.5 of the rank, and negative it is 136.5. So we will take the lowest value, that is 106.5, and expected value, it is n into n by 4, it is coming as your 126.5, and we calculate the standard deviation. Then we calculate the Z value, 136.5, that it was calculated as a this standard deviation, this minimum value, and minus 126.5, that is the expected value, that is x minus mu divided by your standard deviation. What we get, that is 0.3089. So we will now take care of the Z table here, that whether this value of the normal approximation, p value 0.3089, it comes around your 0.6217. How it is coming, I will also show you. 0.3089, 0.6217, 0.3089, that is the Z value. It is coming as 0.31, and the corresponding p value is 0.6217. This probability distribution is 0.6217, and finally we get the, that is 0.6217 and 0.3717, and 2 into 0.3787, it comes around 0.756. So in this case, the calculated p value, it is higher than the p value from the respective table. So what will happen, if the calculated p value, it is higher than your p value that has been at 0.05 level of significance, what will you do? Whether the null hypothesis will be rejected or not? Suppose this is the situation. Z calculated, it is greater than Z at alpha level of system. What will you do? Will you accept the null hypothesis or reject that?
Yes.
Yes, it will be rejected. Null hypothesis will be rejected. These two groups have difference in their medians. Okay. So before going into another example, okay, can you do the ranking now? I think P time is coming on. It is P time is there. Okay, after the P time, let us do the ranking. After we come, afterwards from the P, we shall do the ranking first. Because ranking is very important here. So that we will do first, and thereafter we will go forward. Otherwise, things will jumble here. So take a break, and thereby we will do the whole ranking, how it is coming, and then we will understand. Any questions remember?
Sir, before one slide where you have calculated the AC, standard deviation, you have written the formula of standard deviation.
Yes. Okay, we have some questions that I will.
Previous calculation. Yes, yes, this.
Yes, this is the standard calculations under your calculation of your wind box. One is n plus 1 into n divided by 4.
Theory is only for wind box.
Yes. Not that standard deviation formula. Normally your standard deviation formula will be like this.
ওইটা হবে না
This will be your standard deviation formula normally for a population, and when you get a sample n minus 1.
Sir, another the question of Amul butter and mother dairy butter. You have considered that total number of population is 30.
Yes, that it has been considered there, that considering a normal distribution.
Okay, 6 who have been
Yes,
excluded.
Excluded, yes, that has been excluded. Okay, you can take the break. So a small sample I have selected for you so that you can do the ranking very quickly. There are 10 samples. You can choose from here, calculate the difference of this particular sample. How much difference they are getting. First of all, to rank them.
So what is the first column heading?
This is a sample, this is a group and this is B group. And this is, I have ranking that I have taken care of. You can just write this column and this column. Just calculate the rank here. Simple ranking. Thereafter I will show what it has been done in the Excel.
Sir, A for after, B for before.
Yes, A for after, B for before. So as you can see, if I arrange the data for ranking purpose, how it will come? First is your 4, then 5, then your 7. So it is 1, this is 2, this is 3, then again it is coming as 3,
8 and 8.
8, then 8, 4, and then your 10, 5, then 11, 6, 12, 7, 13, 8, 14, 9, 18, 16, 11. So these are total ranks. So here there is a defect that if I consider this 4 plus 4,
This will be 4.5.
yes, this will be 4.6, 4.5. Or this will be simply 4. Average. So this will remain as such. Basically, this will be done as 4.5 or 4.7. So the sample we have taken in the earlier case, that was that particular sample. First one was 9, second one was 10. The difference, it is 1. The sample which we have taken in the Excel. Let me get it. Here it is. First one was 9, second one was 10, then 41, 39, 64, 67, and likewise. That was the sample. So that was the difference between the sample. That is 4 minus 4, minus 4, this was the difference. So here it is also represented here, as you can see. These are the absolute difference and these are the difference of the sample. 9, 10, difference is 1, 41 minus 39, that is 39 minus 21. This is before and after. So after we will take first and thereafter before. So this is minus 2, then 3, minus 3, then minus 4, minus 4, 4, 4. So these are the absolute differences. Then we are taking the sign. In the first, it is a positive. Since it is positive, it is a plus sign. In the second portion, it is negative. So it is a negative sign. In the third portion, there is a tie. Because 3 and 4 rank will be there. There you are finding here the third and the fourth rank, they are having the same result. Okay, so there is a tie, 3.5. 3 plus 4, it has been converted into 3.5. Here if I calculate this, just calculate the difference of the rank. First one, that is if I consider this is as after and this is as before, this is plus 1. This is after, this is before, again plus 1. It is plus 5 and it is minus 7. Sorry, it is 7. It is 9 minus 2 and finally it is minus 6. Okay. So 12 minus 2, yes. So 7, yes, 12 minus 5. So add the positive one and add the negative one. Okay, that we have done. After getting the rank, we have added the positive one where there is a positive sign and that comes around 136.5. No, that one put in blue. 136.5, that is the positive difference of that particular what it was positive, and that is the negative rank. So this is positive rank and this is the negative rank. After getting this, whatever is the minimum that is to be considered, that we have considered in our Excel that I was showing to you. So base statistic W, it is minimum of W plus and W minus. So minimum here it is 116.5. So expected value, so in normal expected value, what do we mean by the expected value? Normally in statistics, we mean it is a mean expected value. So here in this case, that is n plus 1 divided by 4. Okay. So it comes around 126.50 and standard deviation we have also calculated, that is 30.753. Then normal approximation it will lie between this mean, between the standard deviation and this mean. It is a normal approximation. So thereafter we have calculated the Z value, that is x minus mu by sigma, and here x it is 136.5 minus mu, it is the mean, that is expected value, that is 126.5 divided by our standard deviation, that is 30.75. So when I get the Z value, it is coming around 0.308. So 3089 is 0.31. Now we shall see the Z table in the side. Yes, that Z table is in the side. Go to 0.31. 0.31. 0.31. Or it is coming around 0.621. So here the P value, it is 0.621. But our calculated P value, it will be 2 into minimum of 0.3. 6 to 17 means 6 to 1, 7, again, it is the probability of success, then we have to get 1 minus 6 to 1, 7. That is 0.3787. So 2 into 0.3787, it comes around 0.757. So here, our calculated value, and that p value which we have calculated through the there is a difference. So here we are rejecting our null hypothesis, means there is certain difference there between the two groups. Okay. Thereafter we will come across the another test, that is your man-white test. Again, there are two groups. One group has received the training and one group has not received the training. So there are sales performance of two particular groups. One is before training and second one is after training. Okay. Now you can rank the group now. Now do the ranking as usual. Just let them see the data so that they can do the ranking.
Sir, increase.
You arrange the data. Thereafter you can do the ranking. First of all, you arrange the data. Thereafter you can do the ranking. This is a small sample, you can do it. I have done the ranking, but first of all try it first. So we have got the data like this. 3, then 4, then 2 is also there. Okay, 2, 3, 4, then another data is 5, then 6. 2, I think 2 times it is 2.
Five also two.
5 also 2, okay. 5, 6, then
Six also two.
6 also 2, okay. Then
7, 8.
7,
8, 9,
8,
9, 10.
9, 10.
9, 10. Now you can arrange it. 2 and 2, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is it okay? Are you getting it? Now it is okay. It will help you to understand how everything is being done. 2, there are 2 items there. So 2 and 2. 3, only single. So 3, 4, only single item is there. 4, 5, again 2 items are there. So 5 and 6. Then 7, 6, 2 items again are there. So 7, 8. 7, only single item is there. 8, only single item is there. 9, and finally 10. 10 is also there. Okay, 10 is also there. Now what? Now just make the average. It comes 1.5. So both the final rank, it will be 1.5. Then it is 3, not 2. It is not 2, it is 3. It is 4. Here also there is a tie. I think 5 we have 2 items.
Yes,
5 2 items. So if it is 5.5, then 6 I think it has got also 2 items. So it is
7.5.
7.5 or 6.5?
7.5.
No, it is 7.5. 13. It is 6, 6, 7, 8, na? 15. Yes, 7.5. Then it is 9. It This 10, this 11, this 12. I think with a small sample you can understand how the ranking has been done. Whenever it is a tie, it is generally considered as the average of this group. And thereafter, we arrange the ranks as such. As you got the rank, you arrange the rank. And then find out again the total of each particular rank. Suppose in the first category, 3 was in the third rank, 4 was in the fourth, 2 was in the 1.5, the 6 one 7.5, 2 1.5 again, and 5 5.5. So total ranks of this before sales training is 23, and total rank of after sales training it is 55. Okay. Now we will calculate the new statistics again. Yes. Q it is the same, that is rank sum minus n plus 1 divided by 2. So before training and after training we find out what will be the value of the U. Rank sum is 23 minus 5 plus 5 by 5 plus 1 divided by 2. So whatever you are getting, yes, whatever it is, before training and after training, you will get the U value. Then you have to take the smaller U value, smaller of these two, yes, before training and after training. So take the small value, it comes around 2, and finally the critical value which has been considered here as 6, because average rank of 7.5. 7.5 it ranks, it pertains to the number 6. So what will be again the calculation? Your critical value, it is your U value, it is lower than the critical value. So what is the conclusion now? If your calculated value, it is lower than the critical value, what shall be the conclusion? You calculated is 2 and Q critical value is 6. So what can be the conclusion? The critical value is higher than calculated value. So what will be the null hypothesis? It will be rejected or accepted? Rejected. So before sales training and after sales training, it has got certain difference. Okay. So I think ranking, it is clear to you how you have to rank the data. If you are finding, so what becomes difficult when you have a large set of data? It requires certain package so that it can be done easily. Otherwise, manually we are doing, but it takes a lot of time to do this manually. Okay. So generally we will not do, it is for your understanding purpose that we have calculated the rank like this, calculating in this way. After all, it has to be combined here. Okay. So this is your land whitening. Can we run the Jamovi package here? Jamovi cloud will be okay. So that cannot be done.
I can show the job.
You can show just show the data. There it will come directly. I think you are aware with the Jamovi package. You are not aware with the Jamovi. It is an interesting package. You do not have to do many things. Actually, GD sir, this my mentor has guided me that go for, because Jamovi is a R-based package. So you do not have to do programming in Jamovi. The R will come automatically. If you want the script, that will come. He can show better because he is expert in this particular package. And it is a free package also. So those who are researcher or doing certain research, though you can use the R is the best package, R and R Studio. It is the best package, but still you can use this package also. If you do not have any very better idea regarding programming and all those things. But the package has its own limitations. What I have shown you first, that is another package which is available. You can refer to that also. It gives the results as well as the why these results are also coming.
There are a lot of people using the cloud.
Right?
Because Xiaomi is a free package, but whenever we are going to use it in cloud, so it is a price. You have to give some price for that.
You can download this package also. This package is also available. It is a free package. You can do a lot of work with this particular package. Any type of test, including t-test, normal exploration of the data, then your all those things can be done. Yes, from there you can download it and use the package also.
Which one is more user friendly?
It is more user friendly.
Xamobi or R?
R you require certain programs. Later I will prefer R Studio.
R Studio and R.
Yes.
If we compare R Studio with Xamobi, which one is more user friendly?
Background, it is R. Jamubi is user friendly because you do not require to program.
Let me answer.
Yeah, he can answer it better.
Actually, this is a package look like HPSS, right? And the backend is R and R Studio is the upgradation of R, right? So the thing is, whenever you are installing this package or software, you are running the same thing in R as well as the data-driven method. So click and touch. If you click on that particular test, it will show the output. In R, we need to run the thing.
Yes.
Here, you need to click and it will show your output.
If you
That
want,
is the difference.
if you want to learn the programming,
Jamovi is better.
yeah,
Sound
Jamubi
is
is better.
better, but at the same time,
Limitations are
because
there.
at the same time, 10,000 packages are there. So Xiaomi can't contain all the packages
Yes.
because it's not converted into a Xiaomi version. So it is a new version and it is continuously changing. Whenever we started, the Xiaomi package started from 1.111 and we should not use the current version because it is having some bugs. So we will use the solid version. You just click on over the solid version, it will be downloaded and you can easily use this solid version.
At the same time, you can also get the R programs, means what is to be written in R.
Yes.
That can be also done from the
What is the difference between then Jamovi and SPSS then? Which software we are
SPSS is
using?
the higher version, you can tell it better.
SPSS is the starting with the SPSS containing the price, right? And SPSS having some module, right? But in R we are having the packages. R is a free software. So SPSS having the modules right now, SPSS 29 is running, having more than 11 modules where data mining module is also there, advanced machine learning module is also there, time series module is also there. But you need to pay for that because IBM is not going to use this free as a software.
Sir, I
But
compared with Jamovi and SPSS.
again, whenever you are comparing with Jamovi and SPSS, first you need to know that Jamovi and R, SPSS and R, because Jamovi is nothing, it's a data-driven menu of R version. Nothing else. So if you know about the particular R version, then SPSS, you know the reference, then obviously the
R
same.
is the basic, then the Jamovi.
No, Jamovi, it only gives the result. You do not need to do the programming at the back end.
So in Jamovi we are getting programming of R also.
Yes, yes,
That is the
yes,
beauty
yes,
of Jamovi.
yes.
Yes.
And the third one is the Python. Python is also free.
But Python we need to run program.
Yes, but you can also do the Google Colab, you can do that.
Yes, in Google
Colab, you can do that.
we can in Python you need to run the programs, you need to run the codes, and on the basis of your code it will generate the output. And one more thing, we use your SPSS, the backend is Python,
SPSS based on Python.
based on Python. SPSS is based on Python, and that
Jamovi is
particular
based on R.
Jamovi is based on R. Now SPSS, as because SPSS started very long back, and IBM took that particular software, make the software productive in the market. That's why they are taking the price. But the concept of SPSS behind that is obviously a Python. The script is Python.
Yes,
In coding concept or software is built on Python or
yes, yes.
Yes.
Because in certain cases, for example, everything can be done in R, but you have to learn the particular program or install that particular thing in the R or R Studio, thereafter you can do it. And for graphical part, you can use the R Studio. It gives very good graphics. Now coming to the third part, that is the Puskal-Wallis test. Puskal-Wallis test, we have taken an example here. That is, there are 3 forms. Patient, 5 patients are there, and these 5 patients, they are given medicine. 2 groups are given medicine and 1 group is left. So 1 group is not given any medicine. 2 groups are given medicine. Then what is the impact on the tooth decay? So suppose in industry also, you can do a thing like this again in HR. Suppose you are paying a particular group certain compensation, you are not paying someone, and the third group you are paying a higher compensation. So median compensation, higher compensation, and no compensation. So what is the output or what is the performance of these three particular groups? Or there is a product which can be marketed. One, you send much on promotional. In particular product, you do not spend anything regarding the promotion of that particular product. And third product is that new product, you are spending much more on that particular promotion. So in this way, it can be also classified. Here, the group is same. One is given no medicine. Different groups are there, not same. One is given no medicine. Another one is given medicine A, and third one is given medicine B. Again, we are ranking the data. I have shown it. As you can see, this is the rank. Group 1, Group 2, and Group 3. Again, just now we have ranked the data. Similarly, we have to rank the data. Again, after ranking the data, we will find out what is the total rank of Group 1, total rank of Group 2, and total rank of Group 3. So here total sample size it is 50. Then we will find out this age statistics. So age actually it is 12 by n into n plus 1 into r1 square divided by n1 plus r2 square divided by n2 plus how much sample you are getting r square divided by k minus 3 into n plus 1. Remember one thing, if two factors or two groups are there, you will use the previous test. One was your ransom test or man by group test. If only two variables or two groups are there. So either you can use the man by or you can use the Wilcoxon ransom test, any of the method you can use. But when there are more than two groups, means 3, 4, 5 or like this, then you got to use this Bruscal ones. Now suppose in this case, we find out the age statistics. Age is the statistic which is to be find out and then it is to be compared with the p-value. So that either we can accept the null hypothesis or reject the null hypothesis. In this case, what will be the null hypothesis? There is no difference between before treatment, so all the groups are same. There is no difference there. But when we calculate it, what we found that the mean rank that this is 9.395. It is coming as after calculating 9.395. How we have calculated? 12 by 15, 15 that is n, number of observation, 15 plus 1 into rank of the total sum of the rank of the first group, that is 53.5. So that is 12, 15, 15 plus 1, that is 53.5 into 53.5 divided by n1. n1 it is your 5 plus second sum was 51.5 into 51.5 divided by 5 plus third one is 15 into 15 divided by 5 minus 3 15. So in this way you have to arrange the equation. Number of observations in each group, that is 5, and the sum of the rank in each group, first of all 53.5, so 53.5 into 53.5, that is whole square. Then 51.5, that was the sum of the rank of the second group. And the third one, that is 15 into 5, 15 into 15. And finally, so what we are getting? 9.395. Now, just come to the conclusion here, you can find it. So, degrees of freedom, that is here, that is, there are three groups were there, 1, 2 and 3. So 3 minus 1, that is 2. So it yields the result 5.99. But here you are getting 9.39. 5.99, please show them how 5.99 is coming there. 2 degrees of the freedom and 0.05 level of significance. Yes. It is coming as 5.99. So your value is 5.99 at 0.05 level of significance. But your calculated value it is 9.39 something. So what will happen now? Either this null hypothesis will be rejected or accepted. Your calculated value it is lower than, so higher than your p-value, means at alpha level of significance. So what will happen? Again your null hypothesis will be rejected. Means there is a difference between what was before and what is after. So what's the point? So can you have an example related to industry where you can use this? The Kruskal-Wallis test you can use this. I am giving one example here. Now there were around 15 set of banks 15 banks classified into different particular categories, and they are exposed to different particular period. Suppose COVID-19, suppose your normal period, and suppose global financial crisis period or any other. Same banks, they are subjected to three different periods. And what is their liquidity position? Suppose you want to find out the liquidity position of the bank through any of the parameters, how much cash reserve ratio was there, or something like that. So you can compare whether there was any difference between the three periods or the three periods were same. Similarly, you can also compare with other examples in the industry. So it has got its own relevance, but basically it is used for your biological treatment of field experiments. Basically, those colors. Here another thing I have classified here, as you can see, that we have find out the mean rank, that is x1 53.5 divided by 5. So mean rank, it is coming around 10.7. Second one, that is it is 10.4, and third one, that is 3. Now if we put it in a chart, the difference you can see, group 1 to group 2 is 10.7 minus 10.4. So it comes around 0.3. Then it comes around 3 minus 10.7. 10.7 minus 3. It comes around 7.7. So can you get a differentiation between the groups? Group 1 and group 2, there is very minute difference. Group 1 and group 3, there is a huge difference. Group 2 and group 3, there is a huge difference. So again, a post hoc test can be conducted. That's why I wanted to show that crucial one is there is one post hoc test that is available. I think in SPSS also post hoc test is available. So wherever you are dealing with a large set of data, do carry the post hoc test. What is a post hoc test will do? Post hoc test will check the robustness of your result. Whether whatever you are getting after this rejection for the rejection of the null hypothesis, it will be confirmed by this post hoc test. So in Jamovi as well as in SPSS, after doing this crucial we get post hoc test also. For example, in Friedman we will be getting another test which is Darwin-Conover test. That is a post hoc test. Here also we will be getting another test. So these are the different tests which we have been discussed, and last one is that is the Friedman test. How much time is left for? 5 to 10. So Friedman test is to be done. I will just quickly go to the Friedman test. Open the Friedman test. Accept. Now, now this is the data of 3 different agents. There are 3 different agents in a housing finance company, and they have received some training regarding appraisal of the houses. For example, they are carrying out a calculation that yes, this house will be this much lakh, this is the valuation. So after training, the difference in the appraisal of the houses. Suppose agent 1 is saying that this particular house it is 181,000. Agent 2 is saying yes, this is 182. Agent 3 is saying 183.5. So as we have told that Friedman is the repeated measure test. Repeated means agent 1, agent 2 and agent 3, they are working on 12 houses and finding out what is the valuation. Okay, so this is the result which a company as housing finance company has obtained, that after receiving training their agents are having this much valuation. Now see very carefully what we did in the past. The samples were independent and we used to do the ranking totally. 1, 2, 3, 4, 5, 6, 7 and up to this. But here we will not do the ranking in this manner. Here we will do the ranking. Suppose this is house, this is agent 1, this is 2 and this is 3. Now this is 1, 2, 3. This is 181, this is 182, this is 183.5. Okay. Now which one is the greater one or lower one? This is 1, this is 2 and this is 3. This is the basic difference between that ranking and this. You can also increase it 4, 5. Because it is a repeated method. It is not that all are to be considered. Similarly here it is 179.9, 180 and 182.4. So which one is the lower? Again 1, this is 2 and this is 3. Now show them the ranking. So here, number of samples, that is n equals to 12 and number of rows you are getting 3. Again it is arrow one. And this is the Q statistics, this is the frequent statistics which is to be calculated. But before going into the frequent statistics, let them show the ranking. I have put the ranking. Yes. Yes. This is the ranking. This is the ranking you will get. 1, 2, 3, 1, 2, 3 means lowest one, lowest rank, highest one, highest. The same principle, but the thing has changed. Only 3 parameters or 3 type of rankings are there. Because we have only 3 agents, 1, 2 and 3. So here you will find out we have again added the rank. We have again added the rank. Similarly you will see there is a tie. There is a tie, so we have also made it average. The same principle will follow. So here you will get the sum of the ranks 17.5. So first group it has got 17.5, second 19.5, third is 35. Now show them the statistics. They are getting calculated. Yes. Now 12 into 12 into 3 plus 3 plus 1 into sum of the first group, it was 17.5 into 17.5 plus 19.5 into 19.5 plus 35 into 35 minus 3 into 12 plus 3 plus 1. I think you understand. We are not going into the details because it is beyond the scope and I also don't know how the formula came. Only statistician can tell. So it is 15.29, that is the test statistic. Now you check the table. How much the value is. Then you can check it. K equals to 3 and n equals to, what was the n? Number of observations? 12. Okay, now check it. How much the value is? It is, I think, coming around 6, I think, at your 5% level of significance. No. N equals to 12. 6 point, K equals to 3. K equals to 3. So it is 6.50. Okay. So the result it will come again that there is a difference between the appraisal of 3 particular agents. Okay. And you can also do another test, that is the Darwin-Cornwall test that I have taken from Jamovi. That agent 1 to agent 1, as you can see, agent 1 and agent 2, they do not have any difference. It is non-significant, as you can see. But agent 1 and agent 3, agent 2 and agent 3, their values are significant. So what the post-hoc test can do, yes, the normal test can tell what is the difference, only difference is there, but the post-hoc can tell where the difference is there. So that is very important for you. So this is all about Friedman, and I shall conclude because time is not left over. Otherwise, I had a case study for you also, a regular case study, but okay, it can be done anytime.
Thank you, sir. Thank you so much.